World Spaceflight News Special Report.
So what is this architecture? So we're not changing the ablator, right? It's still AVCOAT, the same formulation of the ablator. But instead of gunning it into individual honeycomb cells on a carrier structure, we're molding it into blocks to do that in parallel with the carrier structure. Same ablator, molded into blocks instead of gunned into a honeycomb. And then in between those blocks, we're putting RTV, or room temperature vulcanizing adhesive, in between. So you can see how this might play out on the Orion heat shield on the lower left, about 300 or so of these blocks. And there's some precedent for this in the past, right? Tiled systems have flown, certainly. SpaceX is flying an ablative tiled system right now. We already talked about heritage and the problems with that. Is that system sufficient heritage to say this one will work? Time will tell, right? So what are some of the advantages and disadvantages? Well, advantages of a block system, and particularly this one, is that you've got what we'd call true acceptance testing and verification of the ablator before you commit to putting it on the carrier structure. So remember with the honeycomb gun, with the EFT1 heat shield, the honeycomb gun architecture, we had these witness panels that we had to presume were faithful representatives of what was actually on the flight vehicle. With a tiled system, you can make your flight tiles or your flight blocks, pull on them, test them, make sure that they're good before you actually put them down, right? So you know what you've got. That's one advantage. Parallel manufacturing we talked about. Cheaper fabrication costs because of the reduction in labor time is a motivator. Faster test article production throughput, again, because you're molding things instead of gunning things individually into cells. We've actually found that the molded ablator is stronger than the honeycomb system. You can, in some ways, the honeycomb matrix actually is introducing little stress concentrations into an otherwise homogeneous material. And there's less density variations. You can control things at the molded block level as opposed to each gunner's hand that day or week into each individual cell. There are disadvantages. We've introduced a new system element, right? So now not only do we have the ablator itself, we have these seams between blocks, an often overlooked portion, but a very important portion. So we have to go characterize that. Will these seams work? Will they hold the blocks together? Will they ablate properly? The blocks have a less capable attachment system than that honeycomb architecture. They're less tolerant to first failure modes, and I'll go into that a little bit more. What I mean by that is, while the blocks may be stronger than the honeycomb gun system, when they do fail, they tend to fail more energetically, shall we say, than the cracks we saw on the honeycomb gun system. Then we also have to deal with the differential recession between the blocks and the interfaces that we've laid out.